Today in pre-calc, we got at the very end of the period to talking about going from rectangular coordinates, which basically just means the standard coordinates you've been using for your whole life. In other words, where you have an ordered pair and the first one is x and the second one is y. And the first one tells you how much to go left or right, and the second one tells you how much to go up or down. Okay, that's rectangular coordinates. Then the new thing for us is polar coordinates. And polar coordinates work on a circular grid instead of a rectangular grid. Looks a little something like this, where the first coordinate is the radius, meaning the smallest circle has a radius of 1. The second smallest circle has a radius of 2, because you go over 2 to get to that one. The next one has a radius of 3. So basically the first coordinate tells you which circle you're on in terms of which circle going out from 0, the first one or the second one. If the radius is 3, you'd be on the third one out from 0. And the second coordinate is your angle. Rotational angles, just like when we're doing unit circle, we start 0 is here and we go around counterclockwise for positive angles, and it would be negative angles that would make us go clockwise instead. So that's just the basics of polar coordinates and rectangular coordinates in terms of what they are. But we started to get to the point where we were talking about converting, but we didn't get very far with that. I just showed you the formulas. So let me just talk to you. First of all, I'm just going to give you the conversion factors in terms of how do we get from one to another. And the easiest one to start with, really, I think, is going from polar to rectangular. Okay, so polar to rectangular means I'm starting out with something like 3 pi over 6. Polar coordinates. This is my radius, this is my angle. Okay, in order to get from there to rectangular, we use the following formulas. Your x value is going to be your radius times the cosine of theta, and your y value is going to be your radius times the sine of theta. Okay, I'm going to come back to why this is so in just a sec. But for this particular example, that means my x value is 3 times the cosine of pi over 6, which is 3 times cosine of pi over 6 is square root of 3 over 2. So 3 root 3 over 2 is my x. And then my y is 3 times the sine of pi over 6. And the sine of pi over 6 is 1/2. So this is 3 times 1/2, which is 3/2. So polar to rectangular, the rectangular coordinates for this particular point, in other words, same location, just written where it would appear on a different grid, is 3 root 3 over 2, comma, 3 over 2. So that's my x and my y. This was my r and my theta. Okay, so that's how we get from one to the other, at least from polar to rectangular, actually. Okay, so let's go the other way. The other way, if we want to go from rectangular to polar, we are going to start out our rectangular coordinates. Let me say suppose it's, I don't know, let's say, I don't know what I want to say. How about just 4, 2? Just 4, 2. Okay. So the point 4, 2 is in rectangular coordinates, and if I want to put this in polar coordinates, here's what I need to use. First off, to find my radius is going to be the square root of my horizontal component squared plus my vertical component squared, or x squared plus y squared. So the r here is going to be the square root of 4 squared plus 2 squared. That's 16 plus 4, so square root of 20, which can be simplified as 2 root 5. That's my r. Okay, my theta comes from doing the inverse tan of my vertical component over my horizontal component. Inverse tan of y over x. So inverse tan of 2 over 4, which is inverse tan. You don't have to simplify it, but I like to when I see something that's easily simplifiable, so to speak. Inverse tan of 1/2. There are no unit circle values where the tan is 1/2, or at least none that we memorized. So I'm going to do it on the calculator. Inverse tan of 1/2. Now notice that in these we're pretty much working with radians. So this is going to be in radians. Check your mode to make sure you're in radians, and mine is in radians. I get 0.46. So I'm going to say theta is about 0.46. Now this is radians that are in decimal form. In other words, like the pi is already in that. Okay? So the calculator can't do it the other way around, basically. So we have r theta, where r is 2 root 5, and theta is 0.46. So that's the polar coordinate version of these rectangular coordinates. Okay, my recording device or something, or maybe my new laptop, is being kind of picky about video length. So I'm going to stop it here and then come back and talk about why these formulas are what they are. So new video for that.